Hi, welcome back to my channel, and for today's video we will talk about the increasing and decreasing of functions as applications of our derivatives for calculus, and we will have to do tests for getting the relative extrema. Okay, so let's start now. So this is actually a continuation of what we've done already on the previous video regarding on the calculus. We're done already with the introduction of the extrema, the relative and the absolute extrema. We're done already with the mean value theorem. So this time, we will do on checking about the increasing or decreasing of functions. Okay, so let's introduce this definition first. A function f defined on an open interval is said to be strictly increasing, this one. On that interval, if and only if f of x sub 1 is less than f of x sub 2, whenever the x sub 1 is less than x sub 2. And these numbers are actually from that interval. So magiging decreasing din naman siya if eto baliktad. Okay. So how does it work? Ibig sabihin lang daw niya is kunyari yung function mo dito yung x sub 1 mo, dito yung x sub 2 mo. So kasi mas malaki si x sub 2 compared to x sub 1, dapat yung function mo din palaki. So that makes it increasing. Pero pag yung function mo naman, since x sub 1 is less than x sub 2, magiging f of x sub 1 is greater than, so magiging ganito siya. Pag ganon. So that is the intuition of this definition. In order for us to use this further, we will introduce first series of theorems. And these theorems, we will apply this in solving or checking if the function is increasing on a given interval. And then we will have to do a follow-up with a test of extrema, although we're done that with the other video. Okay, so first theorem says that suppose you're given with a function that is continuous on an open interval. So take note of that. Your open interval here is denoted by I, and the f prime. So ibig sabihin, f prime is not 0 on I, then f prime is either positive on all I or negative on all of I. Okay, so ibig sabihin, dahil hindi siya mag-zero, so it's either positive or negative siya. Okay, number 2. Let f be a continuous function on the closed interval. So your closed interval here is the AB. And differentiable on the open interval AB. So this is open and this is closed. So if in that case, the f prime of x is greater than 0, lahat ng x na ipa-plug in mo coming from your AB mas malaki sa 0, automatically your f is increasing on that interval. And if ever ipa-plug in mo yung x sa f prime of x, so lahat ng x sa open interval, then automatically f prime is decreasing. I mean, the f mismo is decreasing. Okay. So kunyari, let's say your f of x mo is 3x plus 5. So your f prime of x is equal to 3. So kahit ano pang ipapasok mong x sa, let's say your interval is 0, 1. Kahit ipapasok mo dyan, this is still a constant. So 3 pa rin, it's still greater than 0. So ibig sabihin daw, this is increasing. So we will check this later further. This theorem 2, we call this as test for monotonicity. Yan. When the function turns out to have an either increasing or decreasing on a given interval, then we call this function monotonic, or the monotonicity exists. Theorem 3 says that if a function that is continuous, so take note of this should be continuous at all points on the open interval. So your open interval is AB containing the number x sub 0. And suppose, so additional requirement, f prime exists at each point of open interval AB except possibly at x sub 0. So first is, if f is increasing, so kung kunyari makikita mong f prime of x is greater than 0, on some open interval to the left of x sub 0, so kunyari yung point mo dyan, let's say this is your x sub 0. And in some open interval, increasing siya pa ganun. And decreasing on some open interval to the right of x sub 0. So, pag ganun siya after sa pa-right niya. So, if that happens, then f has a relative maximum. So, ibig sabihin, isipin nyo na ang relative maximum value at x sub 0, sa left ng x sub 0, pa-increase siya, sa right, after sa right, pa-decrease siya. So, if magdi-decrease siya dito, and then mag-i-increase siya sa kanan, then we have a relative minimum. Okay. So this test, we call this as the test for relative extrema. Yan. The relative extrema that we have discussed already on the previous video. Okay, so dahil sa test na to, Theorem 3, yung implication niya, we will find an algorithm on how to apply this on checking the function. So first, number 1, importante is you solve for f prime of x. And number 2, dahil meron ka ng f prime of x, then solve for critical value. Okay, alam natin yan on the previous video. And then, number 3, if your critical values are, let's say, A1 up to, let's say, AK. So there are K, and these are distinct, ha? So there are K distinct critical values. By that, now that you have gotten your critical values, so you will consider creating an interval here. So, dahil may k ka na distinct eigenvalues, expectedly, your interval should be k plus 1 lahat. So, we have negative infinity to a1. Meron kang interval a1 to a2. Meron ka a2 to a3, and so on until makakarating ka sa a sub k minus 1 to ak. So, di ba si ak yung pinakalas na this critical value? Pero meron pa, you have ak to positive infinity. And all in all, lahat nito is there are k plus 1. Okay, so meron ka ng intervals, then you create the table to check for the theorem. And then, you create your test for relative extrema. Okay, so gagamitin natin this for in order for us to solve if the function follows with monotonicity, and then we will be able to define the relative extrema. Okay, so let's consider this example. So first step is you solve for the first derivative, and then you solve for the critical values. Kasi di ba critical values can be selected or can be solved using the first derivative. So we have, what's first derivative? Derivative ni 3x squared, we get 6x minus derivative ni 3 over 4x to the 4. So bababa si 4, makakancel yung 4 sa baba. So you have 3x cubed. And then we will equate this to 0. So mangyayari 6x minus 3x cubed equals 0. So this implies 3x, factor out ko sa 3x, ang mag-iiwan dito is 2, minus, ang may iwan dito is x squared, 0. So anong matitira dito? We have 3x. So factor out natin to, meron tayong square root of 2 plus x. And then we have square root of 2 minus x. Tama ba? Factoring. Okay, you just have to review your basic algebra. Okay, so therefore the factors, so if equate natin to siya sa 0, so we get critical value as 0, another critical value as negative square root of 2, another critical value as square root of 2. So, pag i-arrange natin to, ang una dito is negative square root of 2, 0, and then square root of 2. So, our intervals, so our interval here is negative infinity to negative square root of 2, negative square root of 2 to 0, 0 to square root of 2, square root of 2 to positive infinity. Di ba ito yung sabi ng algorithm? So, because we have that interval, now we will now create our table. So, ano bang kailangan sa table? So, first table is our interval here, and then the value of x on the interval, and then the f prime of x kung ano ang kalalabasan niya, and then monotonicity. Anong mangyayari? Monotonicity. Okay? And then, yung relative, extrema. Okay, so first interval, negative infinity to negative square root of 2. Kukuha tayo ng value belong this. Ang mangyayari, dito yung negative square root of 2. Numbers before this from the negative infinity is pwedeng makakuha tayo ng negative 2. So, yan yung gagamitin kong value ng x. So, this is negative 2. So, ipa-plug in ko si negative 2 kay f prime of x. So, yung f prime of x natin, ano nga ulit yun? That's 6x minus 3x cubed. So, isulat ko dito ha. Scratch lang. 6x minus 3x cubed. Ipa-plug in natin si negative 2 dyan. Kayo nang bahalang mag-substitute. I think yung nakukuha ko dito, correct me if I'm wrong, this is 12. So, 12 is greater than 0. So, anong sabi sa theorem or sa definition na if f prime of x is greater than 0? So, ang mangyayari, di ba? This is increasing. Wala pa tayong conclusion for relative extrema because nagsisimula pa tayo sa negative infinity. So, how about negative square root of 2 to 0? So, anong makikita natin dyan na pwedeng ipasok? Di ba sa in-between negative square root of 2 to 0, pwede tayong makakuha ng negative 1. And if ipa-plug in kung negative 1 dyan, anong lalabas? Kayo nang bahala ha. If i-substitute ko yan, magiging negative 3 and this is less than 0, so this is decreasing. So because our interval has endpoints na with the critical values, then meron tayong relative extrema. Dito kasi wala pa tayong conclusion for that. Okay. So decreasing siya. So negative square root of 2. So ibig sabihin, increasing siya dito, nag-decrease siya dito. Kasi di ba galing siya dito, papunta dito. So ibig sabihin, relative maximum at negative square root of 2. Tapos, yung negative square root of 2, isa-substitute natin sa original na f. Ano yung f natin? Our f is 3x squared minus 3 over 4x to the 4. So, kayo nang bahala mag-substitute square root of 2. Ang lalabas dyan is 3. Therefore, our maximum, relative maximum point is negative square root of 2, 3. Okay, how about the third interval? Yung third interval natin is 0 square root of 2. And so, in between that, pwede tayong kukuha ng 1. And if we substitute natin 1 dyan, ang lalabas is 3. Correct me if I'm wrong. So, this is greater than 0, so increasing. So, dahil decreasing siya dito, papunta dito naging increasing. So, x equals 0 corresponds to relative minimum at 0. And the value, so f of 0 is 0. So, ito pala yung relative minimum point. Okay. How about the third interval? Square root of 2, positive infinity. So, kukuha tayo ng 2 kasi pasok yan sa banga. So, f of 2 dyan, alam natin, kayo nang mag-substitute, that is negative 12. So, this is less than 0, so decreasing siya. Therefore, x equals square root of 2. Ito yung correspond sa relative maximum kasi galing from increasing, naging decreasing. So, substitute natin ng f of square root of 2. Alam ko ang lalabas nito is 3. Correct me na lang if magkamali ako. And then the point is square root of 2, 3. So, ito yung relative maximum. That's it. So, if you have any question or clarification, please let me know. Okay, so let's try another example. Our function f is x squared minus x plus 4 all over the square root of x plus 1. So how do we take the derivative? So f prime of x equals, taas natin itong so derivative of a quotient, diba? So low d high minus high d low over low squared. So kopyahin mo, x plus 1 negative 1 half, 1 half, square root dito sa taas, which is 2x minus 1, minus 1 half, derivative ng baba, x plus 1, negative 1 half, times, kopyahin lang yung taas, squared minus x plus 4. All over, square ng baba, which is x plus 1. So, how do we simplify this? Kasi ang mangyayari dito, magiging 1 over 2 square root of x plus 1 or x plus 1 to the 1 half. So pag i-add ko dyan, magiging x plus 1 na to. So we have 2x plus 1. Kopyahin yan, 2x minus 1. Correct me if I'm wrong. Or if you have any question, comment down there na lang. Pero algebra na lang kasi to eh. Magmanipulate ka lang ng algebraic expression. So I'm assuming that you're done of this already because you're taking calculus na. Okay, and this is minus. Ito, dala ka matitira. So I have x squared minus x plus 4 all over x plus 1. 3 over 2. Kasi bababa na yung, di ba, naging 1/2. Okay. Meron pang 2 dapat. And then, this is equal to 3x squared plus 3x minus 6 all over 2x plus 1, 3 over 2. So, this is equal to 3x plus 2, x minus 1 all over 2x plus 1, 3 over 2. So, yan yung derivative niya. So, taking the critical values, i-equate mo siya to 0. Pero, ang makukuha kasi natin is x equals 1, negative 2, and negative 1. Kasi, magiging undefined to pag negative 1 to eh. So, kasali siya sa critical values. Pero, ano ba yung domain? Yung domain kasi natin is greater than negative 1. So, ibig sabihin, eto, hindi to kasali. Tapos, eto dito kasali kasi negative 1. Greater dapat, di ba? So, the only critical value that we have is this one. In fact, if we substitute this to f of x, so f of 1, ang lalabas niya is 2 square root of 2. So, ating critical point is 1, 2 square root of 2. Okay. Okay, so dahil isa lang naman yung critical point natin or the critical value, so yung interval natin is dalawa lang. So we have the negative infinity to 1 and then 1 to positive infinity. So how do we create our table? So our table is the interval the value of x, tapos the f prime of x, of course, the monotonicity, and the relative extrema. So, una natin isa lang is negative infinity to 1. So, ano yung number na makikita mo sa loob, magbigay? Kasi maraming number actually. So, we can get which one is the simplest. So, try natin yung 0. So, f prime of 0, plug in natin sa f prime. Yung f prime kasi natin is eto, di ba? Pag ipa-plug in ko yung 0 dyan, kayo nang bahalang mag-substitute, ang makukuha ko dyan is negative 3. So this is less than 0. So this is decreasing. So wala pa tayong relative extrema. So this is 1 to infinity. This is kuha tayo ng 2. Kasi pwede siya sa loob dyan. And then f prime of 2. This is 2 over square root of 3. Correct me if I'm wrong. Kayong bahala mag-substitute dyan. Dito, algebra lang naman yan. And this is greater than 0, so increasing. So dahil decreasing, increasing, so it should be relative maximum. So the relative maximum point is 1. Substitute natin yung 1. That's 2 square root of 2. So yung relative maximum point is the critical point pala. That's it. So if you have any question or clarification, please let me know. Okay, that's all for today. Thank you so much for watching. If you have any questions or clarification, please let me know so that we can discuss on that. And for those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. Thank you and have a great day.